produces the AgriPower combustor, manufactured in Pennsylvania and used in over 60 locations, some of which are seen here, to generate central heating for schools, hospitals, and other buildings. The combustor is essentially two large chambers, each lined with refractory blocks, such as these curved roof blocks and these straight wall and floor blocks, shaped with tongue and groove joins to avoid using mortar that would crack with heat. This effectively insulates the chamber against heat loss, which in turn maintains efficiency. Let's build a system of our own to see how it all fits together. At the bottom of the lower chamber, there are long augers whose spiral form moves the fuel mass when they are rotated. The auger feeds the fuel load from one end of the combustion chamber to the other. Here we can see a 3-auger machine. Different size combustors have as many as 5. Now we can finish off the lower chamber. The upper chamber is built with a large gap in the fueling end of the lower chamber so that the heat can enter into the upper chamber. Let's finish building the upper chamber. Finally, the outside of the machine is clad in steel sheets which are welded and bolted together. Now we fit pumps to blow air into the combustion chamber and then a fuel feeding mechanism. The combustor is now ready for the business end of whatever purpose it is being built to supply, a heat exchanger or a boiler, for example. The hot exhaust gases that flow through the machine carry particulate matter which is captured by this apparatus, which uses tubes nested vertically inside one another. The hot exhaust gases pass down one tube and up another. The particulates fall into this collection bin, while the hot gases continue to exhaust. Finally, there is a working circuit where the heat is used directly as hot air, or it goes through a heat exchanger to heat water for central heating. The heat can also be used in an organic Rankine cycle turbine to create electricity with efficiencies up to 20%. And in addition, an absorption chiller can take the heat and turn that thermal energy into a source of effective air conditioning. There is also a control center with sensors in all parts of the machine which make it possible to determine the condition of the combustor at any stage in its cycle. Here, we see Jim Babcock, the designer of the machine, analyzing screens and adjusting a system installed in a hospital. Let's have a look at what's going on inside when the combustor is in operation. Here, we can see the wood chip fuel being delivered into the combustion chamber and drawn towards the combustion area. A major characteristic of the combustor is its fuel feeding mechanism, built with large containers where the biomass fuel, often wood chips, is deposited by truck. From here, it is fed by auger, which we can see operating here, and also by conveyor belt, which delivers the fuel to a table where it is sorted by size and finally inserted into the end of the combustor, all automatically. Finally, in the combustion chamber, it is moved by the augers through the combustion area, ensuring complete combustion. Air is blown into the sides of the combustion chamber to feed the combustion flames and increase the combustion temperature up to 1,800 degrees Fahrenheit. In these shots of different systems, we can see how the combustion chamber looks different in each case. Using the controls, the fuel feed and the air can be adjusted to reduce the temperature and adapt to specific requirements, such as emissions requirements. Sulfur and nitrogen dioxide emissions can be very low with this method. The wood chip fuel has 10 million BTUs per ton, making it very suitable for this task. Combusted ash is collected here as well, with an ingenious auger system at the end of the combustion chamber and deposited in a waste collection bin. There's a very small amount of ash relative to the quantity of heat provided. The size of machines can vary significantly from 2 million BTUs per hour to large 15 million BTU systems. Here we can see a large drying drum which takes the hot dry air from a large combustor and uses it to dry biomass to manufacture pellets. The AgriPower combustor is an economic, proven and highly efficient method for turning biomass fuel into heat and power.